I demonstrated to you last time that we had this thing called string, which under the hood is nothing more than a string array, a character array, which itself is a special type like ushort, the 16-bit integer number that refers to the code units in UTF-16, which is an encoding format for Unicode. The system that has effectively just a large table that tells us this number represents this specific character, symbol, emoji, space, whatever. We have a special type for that in C#. Tell us that this number represents a special symbol, a character, usually. That's why it's called character. Though specifically it represents the code units in UTF-16, so you might have a single symbol that requires more than one character to be represented by, though simple characters, like just your standard English alphabet, is perfectly capable of being put into a single character. But even if all you need is one single character to represent your symbol, you probably want to have some more characters. And to combine them, we use this thing called array, which we talked about 2 or 3 streams now, to get a sequence of individual symbols. Because that's very common, in C# we have a predefined type called string, which is just that. It's one of the many types that come with the language, that you don't have to define yourself. They were defined by the creators of the language or maintainers of the language. They're just there. They have special keywords. They're fully baked into the language itself. With string being the odd one out, because things like char or int or bool, they all are value types. They represent a single value. And string, since it is essentially an array, represents a reference type. So in that regard, it's a bit the odd one out. I also showed you that string, let's say this is a string, can be quickly defined by writing out the text and putting that in double quotes, compared to the character, which would be singular ticks, single quotes, like that. And of course the char array could be created like this. We want to be formally correct. Or we simplify it because it's an array. Do it like this. So, of course, it's a bit easier. And lastly, since it is essentially an array, we also have access to certain features that you get with an array, like accessing specific characters within this array S by using an index, using the same syntax you would use for an array. The distinction being I can read a value, no problem, but I'm not allowed to write it. So unlike with a normal array, I can't, do this. I can also do this to get the total length of the array, or in this case, the length of the string. Because calling it a character array is misleading, since it is a string which wraps around a character array. But as you've seen, I have some rules that don't apply to character arrays, so calling it a character array is wrong. It is similar because in the background it is a character array, we just change how we access it. And this length, of course, came from just arrays in general, which were sequences of elements in memory, where you just have a single value followed by another single value, followed by another single value, or as many elements as you want, directly one after another in memory. For value types at least. For reference types, you still get values one after another, though that's just the addresses, and the actual values would be spread out all over the heap. And this sequence of individual elements had this additional header data that would include things like how many elements are there in the sequence. That's stuff we talked about. I demonstrated that badly with a little sketch. And so arrays were this special type that would internally store a sequence of elements of whatever type you want, but it comes by itself with some features of its own, like the length or long length if you need to have something really big. And the funny thing is, it makes sense for array to have some special features, because arrays are a bit special. They're not just a single value anymore. But I also showed you this, for example. Which would get you part of this string on top. It's a method we can call on this type, just as we can access this property, the property field. We can access this method, which is part of this type string. Just excuse me for a moment. Got something stuck there, had to get rid of it. So just as the length field is part of the type, so is this method. Just comes with strings, because strings are fairly useful. There are a lot of things we want to do with strings, and so we don't have to work on that ourselves, because sometimes we can really, not efficiently anyway. The creators of the language provided us with existing code that lets us do that. Someone already wrote a method called substring for us, and we can just use it. We don't have to use it. We can write our own method, but we could do that. It's here, we can just use it. And it's not the only method. There are a lot of other useful methods we have in string that lets us access strings in a more standardized way, in a more simplified way, because we don't have to think about the details how are strings implemented really, because they are technically character arrays, but we're not allowed to access them in a way for safety reasons, for efficiency reasons, but actually for safety reasons that apply because we made efficiency concessions. Anyway, makes sense that we're provided with extra tools to help us navigate strings and their special rules. Things that we wouldn't really need as much if we just had a character array, where we would just do everything ourselves anyway. Only, even for a character array, we do have methods that already exist that we could use. Even if it was just... Can type again? There we go. Character array. Let's initialize it like this. Let's be very creative. 1, 2, 3. I said 3. There we go. Let's say I want to have just the last 2 elements. I only want these 2 in my array. I want an array where only those 2 exist, only 2 and 3. So following that schematic, let's do CA2. I could go the direct route and just make one myself. I could base it on the old one. Like so. That's valid code. Or be fully dynamic and not worry about anything in CA. Just create a new character array, make it as big as CA -1, because we drop off the first element. And then for in print I equals 1, I less than CA dot length plus I, like that. And what we do is CA2 I -1 set to CA I. So this for loop will iterate through all the elements in CA except for this first element. We start at index 1, so at the 2. And we just copy them over into CA2. But when we do, we have to move the integer back, because index 1 in CA is supposed to be index 0 in CA2. And index 2 in CA is index 1 in CA. So always subtract 1. Alternatively, we could, of course, start with a j at 0, and then make a ++ j in here. It's mostly a matter of taste. I'm adding additional calculations in here instead of reserving extra memory, which itself would require calculations, so this is... In this case, it's a bit faster. I think it's faster to write. It's easy to understand. Just saying, there are always alternatives to writing this stuff. Anyway, this would be the code to get the substring, so to speak, starting at index 1 from CA. This is what we did up here as well. We created a new character array, internally a character array. We see only the string part, which is part of this original character array. But we start at S. 0, 1, 2, 3. That's where we start. Well, for this kind of stuff, where we copy out stuff from another array, we wrote a for loop ourselves. But there are lots of arrays in your program usually. Some are larger, some are smaller. And you will do a lot of copying stuff over from one to another, especially if you work with low-level code where you have maybe byte arrays to move around, which you might rarely do, depending on what your position at your work is or what projects you're working on in private. But writing this out by hand every time is unpleasant, so you would, of course, come up with your own method. Copy, for example, char A and char B and start at something like that. I'm just gonna copy that out of here. Wait, we don't want char. Yeah, No, let's put that out here. Let's just make it... Let's make it even simpler. Let's keep it the way we have it up here. Create a new... say 2. Let's copy that out. We'll start at... minus start at. That's basically our offset. And then we can return CA2, like so. And then we can, not CA, yeah, no, CA2 is fine. Copy CA1, like that. We simplified things a bit. Better. I should probably introduce some error correction, like what if this is already smaller than start at? Like this is only 3 elements right now. What if I'm starting at element 15? That's probably not a good idea. This will be a negative number, which will cause the program to just break, because I can't make an array with negative amount of elements. I can make 0 elements, not negative amount of elements. So that would break the program. I should take care of that before it gets to that crash. But if we ignore that for now, a simple method to just do the job we needed. And because this type of method is very common, you will use it throughout all your programs, probably. And at some point decide, I don't want to rewrite this every time I create a new program. I will put it somewhere to share it between all my programs. And how you would personally do that is a topic for way later. But there are ways to do that. And if the method is so fundamental and so common that it's used everywhere, all the time, and maybe you should have a look if the creators of the language, or maintainers of the language, haven't also decided this method is so important, so common, that we just put it within the language itself. If you get the language, if you write code for that, we just give you a selection of code and we put that in there, because we know you're gonna need this. And you can just have it. No need to write it yourself. I mean, it's just a few lines of code. You have to rewrite every time you create a program. No. You just get the code for free. It's in the language. Just use it. Just as we use substring directly or access length directly, instead of fiddling around with the sketchy underground part of the language, we can access other code that is given out with the language. And this code can be accessed through specific classes that are predefined already, specific custom types that exist. Like our basic data types, like string, like jar, we have a bunch of other classes that are sometimes data types, but not in the sense that they represent a basic value, like a character would or an integer would. They're the same type of custom types, of custom data types that you would create. They're classes and struct and plenty of other stuff that come with the language that you just don't see yourself, because they're helpful, very helpful even, make your life a lot easier, save you a lot of time, but you don't need it technically to write the language. So they come with the language, they're not part of the language. If that makes sense. It's like, if you mention the language itself being some basic words, some basic vocabulary, and of course the grammar rules mostly. And then the creators decided, here are some books to read. We give you a full language and here are some books you can read up on and maybe quote from. Doesn't really impact the language itself, it's just an example of how we use the language, and they are the most common ways you use language somewhere in these books. You don't have to think about that yourself, rewrite that yourself every time. You can just put a quote in, reference one of our books, and whoever reads your code will then understand the quote and see where they can read up what to read next. Citations, basically. I just want to copy an array. I didn't write the code myself, but you can reference the code for copying this stuff somewhere in this book that came with the language that you already have. Because you also know the language. So I know you got the book as well. That kind of stuff. Substring and length were examples of that. They were code provided in special classes. Or actually, in a class. No, yes, classes actually. Those are still classes that came with the language. So I'm cheating a bit. It's not that string comes pre-built in with a method substring. It's that string refers to a special type in C# that comes predefined with your language. Even though, yes, it is a character array and fundamentally baked into the language because it's a keyword, in reality it just references a predefined custom type someone created. And in the same way, any array is just referencing a predefined custom type in the language. And these types have lots of methods and sometimes extra fields. CA.length, arrays have a length. Strings have a length too. Strings come with extra methods you can run that apply to this. And so do arrays. They also have special methods you can call. Though most of the time when you use these predefined methods on an array, you're not calling them on the array itself. You probably call them as static methods because, of course, all this predefined code has a lot of static methods. And for that you would use the class array, which is not a data type by itself. It's not like I can just create a new array A and store stuff in there. I mean, kind of yes, but also no. Don't try that. You can get an array instance, but that's not a good idea to work with unless you really need it in some special circumstances. Don't think about it too much. For the most part, you see this just as a class called array, which has some useful static methods, like a copy method. And you would provide arrays in there. There are a lot of other useful methods, and we'll get to see them in the future. Some parts of that at least, I think. And they're not the only ones. Even something as simple as equals 0. The integer data type. Int is a keyword, and an integer is just a signed 32-bit integer number. It is a simple value, straightforward. It is also referencing a custom type. Though the real name is not int. That's more like a nickname. That's the one you use. That's the keyword. The class that's referenced by this is int32. You can see it's an uppercase, int32. That's the actual type. There's also, for example, an int64. This is a long. So the keyword int would refer to int32. The keyword long would refer to int64. 64-bit integer. Just an example. All the predefined types that you know have a corresponding custom type predefined by the creators of the language, not baked into the language itself, but just not customary, what's the word? It's just giving it to you as a side. Technically not necessary to run the language, though it kind of is. It's a bit weird. It's this weird gray zone where it technically is part of the language, but then itself it's also just a custom type according to the rules of the language. Languages are weird. Sometimes. A lot of the times. All the times. You usually don't see those names. You usually always use the short form version, which is very easily identifiable. You know them, you love them, and they're highlighted and everything because they're keywords. And these custom types don't just allow you to store a single value, but come with pre-existing variables, fields, constants, methods, whatever. Which, for something as simple as an integer, might not make too much sense. Until I show you some examples, maybe. We can access it through just the short name. Technically, I would go do it like this. We have a class somewhere, a predefined custom type, integer 32. And then I use the dot operator to access some static value. Class name, dot, static variable, static field, or static method, stuff like that. I just do it with the short form. And one value that you might be interested in is max value, which is not a static field, but a constant. Max value is the biggest value an integer can hold. If you fill it up to the max. If you add one more, you would get an overflow and get into the next again. And we have a counterpart to that, which would be int min value. Basically, all the types have this, a max value and a min value. You rarely use them, but if you need them, it's very convenient to have, because it's just a constant, not even a static value. You can just put it in there, you don't lose anything by referencing those. The static methods that we have in there are a bit more interesting and maybe are what you're gonna use the most in terms of class features. Specifically, interaction with other data types. More specifically, interaction with strings. At least in the beginning, it's gonna be the most used type of method. Actually, why did I remove that? Let's just keep that in there. Like that. That's our integer. And I have a string s, put like that. And I also wanted to store 2718, like that. But I don't want to write this out. I want to use the value in I. Well, I is an integer, s is a string. I can't do this. Or we run that, I just cast, right? This. But string and integer are not compatible in that way. When we talked about casting, you learned that sometimes you can't cast because there's just, the computer has no concept of that. This is one of such cases. And to make this work, we can write code that tries to translate this integer piece by piece into individual characters, the 2, and the 7, and the 1, and an 8, and combines those into a character array formatted in a string. Can do that. And that's honestly one of the exercises you would usually do. I'm not gonna give you homework this season, but if you're interested in, that's your challenge. Try to write some code that would take an integer number and convert it into a sequence of characters for a string. It's an interesting problem, but simple enough to solve for first timers. Anyway, the method itself, while a nice exercise, is common enough that it's part of this standard set of code that's given to you. And in case of the integer, we can access that with a dot, which should confuse you a bit, because I is the basic type. I is not a custom type. It's just a value. It's the most fundamental. It's an atomic data type. Why do I have a dot operator? Because int actually refers to int32, the custom type. We can use it like this, which in this form is just a value. But we can also add the dot operator, and in this context, the computer treats it not as, oh, it's just a simple value. Oh, you mean it's referring to the type. I see. You mean the type int32, which has its own set of values and methods and whatnot. Note I don't write int dot like I did with the static method, or with the constants max and min value. I do it on I itself, on the variable. This is not a static something, this is specific to I. To our one value 2718. I can call the dot operator. The computer will switch tracks and see this not as a value I call a method on. It sees it on a type I call a method on. An instance-based method in the type int32. And the method I call is called ToString, which turns this integer into a string. And that's all I need to do. This method, ToString, returns a string, as in this data type, string. And it does so based on whatever value we have in int. And for our purposes, it's doing exactly the right thing. It's taking this value, converts it into a sequence of characters, formats that into the data type string, and gives that back. This is the result. ToString is a special type of method actually, which every type has. It doesn't matter what type you have, every single data type in the entire language, no matter what you're working with, will have a method called ToString. Why that is, we'll talk about another time. Just know, it doesn't matter what you have. It can be integer, a bool, a double, or even another string. Even strings have it, even though it's not that sensible, it just returns the same value again. But it is there, it exists, and you can call it. It even exists for your own custom data types. So if you don't provide specific code to tell the computer how you want to generate strings based on your own custom types, then the output will confuse you more than anything. You can ignore that, but it exists for everything. We'll talk about it at some point. And it's a method that will generate a string from whatever you have. And for integers, it's doing exactly the conversion, this text as actual text and not as the number. Let's reverse the situation. I have a string with this text, and I want that as an integer number. Same as before, I can't assign a string directly. This doesn't work. I can't cast it because it's not compatible. Unfortunately, there's no convenient to int like this. Doesn't exist. There's something else that's very close though. When converting the integer to a string, that's a straightforward operation. You can always do it. Do you have a valid integer? Then you can guarantee that you can generate a valid string that represents that integer. It's just a number after all. It's just a sequence of a few characters. We have only 32 bits, so there's a very strict limit on how many characters you might need. At most you add a dash in front to make it a negative number, and that's it. You can always convert an integer into a string. Turning a string into an integer, possible for a situation like this. Not possible for this. What number is this? That's not a number. I have a number in here now, but there's too much other text. Can't turn that into an integer. This is technically a number, but it's way larger than what an integer can store. I can also not put that into an integer. There's nothing in here, so I can't turn that into an integer. This is a valid integer. This is also a valid integer number if we would try to convert it. So we can't guarantee that we can convert it. We can't just turn it into something. But we can try to turn it into something. We can interpret this number and figure out what number it represents. There's a layer of abstraction, of interpretation, of uncertainty. That's important to know. This following code can fail quite easily. This process of turning a string into a number, or generally turning one piece of data into some other data, by interpreting the information, picking out pieces of information that are encoded in there. There's a term for that. It's called parsing. If we want to turn this into an integer, we parse this string into an integer. Which is a common act, even though it's quite dangerous in some circumstances, if you're not careful enough with the error handling. But because it's common, we have predefined methods for that, and they are not part of the string. String doesn't care about your data types. They are part of integer. int32 has methods that deal with strings, like ToString, but in reverse. And they're specific for turning string, always only string, specifically string, into an integer. And what we're doing is called parsing. So the method we call is int.parse. Parse is a static method in int32, a method that exists already, that you have already available to you with your code as standard part of the language. And we can call that method with the dot operator on the class, just as we can do with any other static class, even though int is kind of weird type to call methods on. And we just provide it with the string that we want to parse. Could also do like this, just give it a string directly. Yep. But we want to do it with s. And this will now attempt to convert whatever data we have encoded in this text into an integer. It will attempt to, it might fail. And if it fails, it will cause an error. It will cause your program to fail. Because computer has never learned how to deal with this. Something must have gone wrong if you attempt to parse this into an integer. Either you fail to teach the computer how to do that, or you gave it the wrong number, or maybe it called the wrong code. This, however, would be fine, and then this method will simply return 2718. Just with ToString, creating this parse method on your own is quite a good exercise, though compared to the conversion to a string, it's quite a bit more complicated. So if you want to do some exercises, these are not homework assignments, no homeworks this season. But if you need some exercise, first try to write code that would turn an integer into a character sequence, into a string. And once you're done with that, try to write the reverse, a parse method that would take a string and turn that into an integer. Oh, for the exercise I should mention this. If you need a string, custom string, you can simply take for example like that, and then do that. String is a reference type, so of course we have a new because string itself is a character array, so naturally we have a constructor call. String actually has several constructor calls, and one of them accepts character arrays, and this will create a string. That's just this. So if you want to create your own string, you can do that by creating a character array, piecing that together, and then passing that on into the new string constructor, which will give you a normal string with that same data. That's one method at least. Alternative would be you can do, of course, that b equals a plus b. Addition for strings has a special meaning, which is concatenation, which will give you just ab then. So if you try that exercise, it's probably easier to just work with the character arrays that you feed into the new string constructor to get an actual string. Or you work with character arrays, period. Up to you. Anyway, that's the parse method. That's if you are certain that you can convert this and trust the process, just get me the integer. If you're not certain that this can be converted at all, then maybe instead of a parse method, you need to use a parse method with a t in front. There's another parsing method in integer that we can call that doesn't assume the data just works. It will attempt the parsing, but it will just say, no, can't do, if it really can't do, instead of breaking the program. It will try to parse the string. So we call it TryParse. And you might remember this format because I'm fairly certain we discussed the shape of this method. This method will receive the string we want to parse and will try to do so. And it will return a Boolean value. It won't return the integer value that it successfully parsed if it can. It will return us a Boolean that tells us if it was able to parse the string. So in this case, it would be false. For this, it would be true. How do we get the value then? Well, we can just call int.parse, right? If this was successful, we know we can parse it, and we call just parse again. Or we do it the correct way, like this. This format, very, very common, especially for parsing. you have a method that will return a boolean to just tell you if something worked or not. And the data it needed to generate or work on is given to you in the out variable in the back. And usually they're always called try something. For parsing, they're called TryParse. You give it a string, it will try to parse this string. It will return a value telling you if it succeeded or not. And on the out value, we will get the value it successfully parsed. And if it failed to parse it, this will just be a default value, as in the default value, with the memory set to 0. Which for integer is just the integer value 0. If this was a different parse, if this was a different type of method, still a try method with an out variable, it's probably going to be null or something like a reference type. Because memory all zeros is the default. That's not a guarantee though. You always should read up on what happens in which scenario. If you see a try method, look up the documentation for it and figure out what the out value will be exactly, especially in case of a failure. It's usually just a default value with all memory set to 0, but read it up just in case. Or don't trust that value at all, just simple as that. And often you don't store that as a boolean and just put that into a branch somewhere, for example. If TryParse and, or if not, also very common, if not. Example, this case, I want to ensure that I have a negative number if I fail to parse, or double down and make sure it's a default value 0. But that's up to me in the end. Sorry, I'm kind of spaced out there. Didn't get enough sleep last night. All right. Working with strings is surprisingly important in your program. Or maybe not surprisingly, because you need to communicate with a user, most likely, at least to present your results. And using plain English is often easier than having some weird codes that you only understand if you know exactly what in which order is supposed to come out of your program. So of course it makes sense that we have methods like ToString, which will convert your data into a string to make it easy to read. And also methods that parse strings into something sensible for the computer to understand input you give it. Now for input, we're not going to talk a lot today. That's not the goal for today's lesson. But I'm just gonna leave you something that by now you will understand. This method, public static void main, is the entry method for our program. Talked about that. We need something static so we can call a method without having any instances yet. We don't have code to create a new program object in memory, so without that code to create the program method, we don't have to create the program instance. We don't have an instance to call non-static methods on. So we need a static, and we need some identifier to make sure that this is the one entry point, not in any other methods. And by convention, that's just main. Just predefined somewhere. Look for the method called main. And when you now start your program, which on a Windows system would be the executable.exe file, the computer will initialize the memory, prepare all the interesting stuff about your program, and then call the method main. The interesting part about programs, not just on Windows, but on any other OS as well, is that when you start a program, again, on any OS, that's very, very old feature, very useful for so much stuff. You can provide the program with data before it even started. You can tell the operating system, here's a bunch of extra data, give that to the program to use once you've started it. It's a very special type of input. You prepare data beforehand and hand it over to the operating system, and the operating system will then pass it on to your program once it's up and running, when it starts the entire process. In our program right here, we ignore that. We don't provide any way for the operating system to pass on that data, so it just, okay, I guess I'll just drop it somewhere, doesn't matter. We can change this method so we actually accept that data, so we can use it. So whoever started the program can pass data onto us before we even start running, and we can use that information. And this extra data is provided through the command line arguments. Depending on how savvy you are with computers, you might be aware of it, or maybe not. But when you start a program, let's say we have program.exe, we can just call it. But if we call this program through the command line instead of just double-clicking it somewhere on the desktop or wherever, we can tell the computer start program exe, but then list some other values. And these are all strings in the end, just plain old strings, that will be given to our program when it starts. These are command line arguments, because they're individual strings, or maybe you can call them words, that we give to the program as arguments that determine how the program operates. That's very important for programs that don't have a custom UI, programs that just work in the background. Lots and lots of stuff happening on your computer right now is done through tools that you don't see. If you have some kind of task manager, some process list, something that lists exactly what programs are running on your operating system right now, many of those work entirely without any direct user feedback. You just start them and they do their thing. And often those tools only work for a short time. You just start them, they do their thing, and they shut down. They're not running permanently. And the easiest way to provide them instructions on what they are supposed to do is using command arguments. You just list a bunch of strings, which can be certain arguments that just act as a flag. Actually, the specific format here can be very different. By the way, there is no meaning to what this text right now is. There's no standard for that. It doesn't matter. It's just strings in the end. And the tool then will read those arguments, which could be anything to trigger certain effects, behaviors, or common is to include something like the full path to a file on your system, because you expect the tool to work on that file, to use it for something, modify it. And the program will just do that quickly. Maybe put out something back to the user who called it. We'll get to that in a few minutes. It's still happening today. We'll get our hello world. And then it shuts down and it's gone. And that's very common behavior for a lot of programs that are running on your computer all the time. If you have a list of the running processes, like Task Manager on Windows, you will see a lot of activity. Programs that start and stop and go and when everywhere. And if you have this process list, you probably have a way to display the arguments that were given to them when they started, because the operating system remembers those, the command line arguments. Depending on your operating system, there might be different visualizations for these processes and different ways you can organize what data you see in that UI for you. On Windows, you have to right-click on the headers. You go to the details view and then right-click on the header and select the columns you want to see. And then there's a specific column for command line or command line arguments. They're just command line, I think. And they can read all the command lines that all your programs were started with. And you will probably notice quickly that most of those programs have command line arguments. Very common way to pass on input to your program. And to make use of that, well, it's input. We just have to provide arguments, parameters for our methods. All of this stays the same for still the same reasons. It's just that when our program is called, or when the main method in our program is called, we need some way to accept strings, string values. And we do that through arguments in our method. And because we can have multiple arguments, we don't just accept a single string, we accept an array of strings. And usually would just, it's arguments, but usually would shorten this to args. For arguments, just a shortcut. Oh, my throat hurts. Too much talking yesterday and not enough sleep. Wow. Okay, this small modification means that our program is now capable of accepting input provided through the command line. Oh, I should mention that if you want to experiment with it, you can do that through the command line, of course, but if you have shortcuts, if you create a shortcut somewhere on desktop, for example, for a game, if you open the UI for that shortcut, there are extra fields where you can define arguments or where you specify the call to your program, which is the full path to your program, but also more, just like what I did here. You can put that into your terminal to call it through the command line, as expected. But you can also put that in the configuration for a shortcut. And then whenever you double-click the shortcut, it will still include the argument when calling the program. Also very commonly done. For games, if you have some kind of launcher, they usually have settings to include arguments. You might have done that before to access special features or to debug something, to make it work, to fix it. And that's so standardized across all operating systems for all kinds of programs. It's rare for me to find a program that has 0 arguments. It's not always extensive, but it usually has at least a few possible arguments. Because it's just way too convenient as an input method. If you start your program, you can simply check, do you have any arguments? And if so, you can access them individually. And you get normal strings that you can then check for things like if a then do one thing. So if I call it like this, then this will be true. If I do it like this, then this would be false. And so I can provide input when calling the program to change the behavior internally. I can't fully demonstrate this in this online version of the editor, or at least I don't know how. It has input, but that's a different type of input. But if you're running this on your machine, then you can try that certainly with just the command line, calling the program directly and passing just values onto it and seeing what the array contains. That's very easy input in the form of strings that you provide when starting the program. The easiest, most fundamental way of passing on input to your program that works basically everywhere nowadays. That covers the input. It gives us the full signature for our main method. Or one of the full, technically not the full method. And it's only one of the valid. Ignore what I said. We still have to cover the output. How do I get something back from my program? As I mentioned, we have this large book of existing code that we can just reference and quote whenever we like. And so far we did that through types that we actually interacted with before. Method and string, or int, or just in array, which is a weird class because we never write it as array, but we still had arrays, so that made sense. The vast majority of pre-existing code comes in classes and structs and other stuff that we haven't seen at all before. And part of learning a language, or maybe the biggest part of learning a language, is learning about all these different classes and structs and things that come pre-packaged with the language. Learning the language itself is the smallest part of learning any new computer language. It's like you might understand the grammar and you have some basic words down, but the day-to-day conversations, if you learn a new human speaking language, are something you learn by doing. You have to listen to stuff, you have to read stuff, you have to actually live in the language to really learn it. Because otherwise you can say hello and maybe ask for the directions to the next train station, and that's where it stops. Same with computer languages. You understand the grammar for the most part, and you have some basics down to do simple programs, but to really program, you need more. You need a lot of extra knowledge of just remembering different classes and using them and understanding how they work and what they do and when to do that. And the first thing we're gonna learn, the first important class you're gonna interact with, is this class, console. Console is a special class that surprisingly deals with the console, which is the medium through which you interact with our program. At least in the simplest case, our program, our executable, will be a console program, as in it doesn't have a dedicated UI. It's just a computer program, and the most basic interaction you can have is through your console, or terminal, if you want to use a different word. Which you don't get to see on a Windows-like system, as in a fully UI-based system, where you click on things with a mouse and have different icons you click on, pictures, and drags things over. Under all of that is still a system that's running on consoles, or simple text input and output. And of course some pure data that even the console doesn't show. A different topic. So a console is one of the most fundamental classes in C# that you're going to use for so many things at some point, at least. And there are lots and lots of different methods in here and properties or fields. And the one we're going to interact with now is a static method called write. Not written. Right. That's better. Because the console is essentially just the text terminal you see when you start the program or run it, assuming you use the console. Again, it's a bit weird since you have this mixture of, under the hood, your operating system uses these terminals, but what you see is probably all fancy images and windows, and not the operating system windows, but the concept of rectangular viewing, whatever. Anyway, you don't think about it too much, but every program is running on a console and has the ability to write something to that console. Which could be anything. Just simple greetings, status messages, errors. Everything could be written to the console as a simple, direct textual feedback for the user. And console.write lets us write something to that console. It's like we're sending a message to the user through the console. If you must, imagine it like a chat window. Right now, our program is writing something to send it to us. The console window, the terminal, is the entire chat log, and we write something into the window to view. And what we write is, of course, text, which means string. And I'm going to make a shortcut here. I'm not going to store that in a variable. I just put that directly in here. And the most classic text you can write is the good old hello world. It's one of the most fundamental ways you start learning programming, usually. A new language is, hey, this is hello world in this language or this language, because it's the fundamental code that you need to get a program running and to output something, just to show that it is successfully running. And for us, that's working through console.write. Please write something on the console. Static method in this class called console. And if I run this, even this editor, let's ignore that. Yeah, okay, maybe you should. Forgot. Was hoping I could move this to later, but we have to do that now. So what you were supposed to see down here is hello world. Instead you see the error message. Console does not exist in the current context. Well, let's take this as a lesson to learn, because that's of course the intention. This was totally intentional. Let's learn about more error messages. Console does not exist in the current context. It means the computer doesn't know what console is. It understands that it represents something. It could be a variable we have, or it could be class somewhere. It knows it's something that we could access through just the name that we can apply the dot operator to. But it doesn't know what it is. Even though it is in the language, our program never specified it. It's never referenced anywhere else. It's only in here. We never wrote a class for console. Excuse me just a second. Maybe doing strings in the morning wasn't that great of an idea after all. Okay, but let's just assume this is a one-time deal. Oh, next time I'm going to sleep earlier. So, yeah, we never defined it ourselves, so the computer doesn't understand what this is supposed to be. We have to tell the computer that we want to reference something. We have this other book that we're quoting in here, but we never left a footnote that tells the compiler, hey, look this up here or there. Like, we never explained, oh yeah, 2. we're missing that part. We're missing the citation. And unlike with normal citation, or at least the ones that I'm used to, where I put it in the footnotes, the footer down there, put it up here in the header. We need to put in a reference to what we're quoting here, what console is, where it comes from. And the way we do that is with a special keyword, using. It just starts the whole file, the entire program, and it tells the computer for the following. We are using this reference, and we're using this other reference, and we're using this part from this book, and we're using the stuff mentioned in this other thing. Just to preface everything and just to get the computer to understand, please look up all these references, use all of that, what we're providing here, and then try to understand our program. Because without it, you're gonna get lost. If you don't have the references, you don't get the jokes. And what we're using in this case is the, well, let's say book system. System is one of the most fundamental references you can make. It's not the only one, but it's basically the root of everything. And now that the computer understands we are referencing this thing called system, as in the fundamental system, the base system for C#, I understand this reference. I know what console is. It's written in system. In system, there's this class called console. That's what you mean. So I can call the static method write of this class console that I find in system, that's written in there, and I can call it, and that will cause this output to appear on the console. Now that we can make outputs, we can make another text appear as well. Oh, whoop, not intended. Please go back. The output looks a bit weird though. This is a distinct text and this is a distinct text. Two different strings. But in the output, they're just written one after another. No space, no new lines, nothing. Just as one continuous piece of text. Because that's how the whole thing works. We define everything a character. And a new line like this is itself just a different type of character. Control characters are still characters. The space is a character. Even though it's nothing that needs to be drawn, it's something that needs to be still considered when writing text. When you make a new line, you have to be aware that you want to make a new line here, or at least another space. You would have to add a space in here for it to make the space in here. Not because we need to draw anything in there, but just to tell the system, please do nothing for a bit of space and then start with the next symbols. And if we want a new line, we have to tell the system, please continue this text on a new line. And the simplest way we can do that in this case, well, not the technically it's not the simplest way. Depends on who you are, I guess. What I consider simple, but we can use a different methods. Instead of write, we say write line. We do that in here too, just to make it more consistent. write line means don't just write this text to the console. Whoop. Once you've written it, add a new line. Go to the next line, hit enter. And so we go from here to the next line, and we're here. Whoop. That's how we get a new line. Could also, we want more space, and we're lazy, we could do this. Have nothing in here except for add a new line. We could also do this. Write line doesn't need anything. We could call it just like this. There's another method called write line that doesn't need any strings, and it's just completely empty, and all it does is write a line. So write line is actually a method that's writing the new line. That's hitting enter for you. But we can also provide it some text to enter, to write out, type out before hitting enter. And write line would be the most direct way you can provide output from your program. String args, the string array we get in here, is your command line input, which is the simplest way to provide input to your text, to your program, which you can use as is for just comparisons. Is this equal to something else? But you could also do the method you just learned about. Like this. Whoop. Let's not call it input, let's call that A, let's call this B, second command, and then we can do in C equals A plus B, and then we can do C dot to string like this. That would combine everything we learned so far today. We get a simple input through command arguments, could be 1 and 3, which would be interpreted as integers if we write it as code, but as command line arguments, these are just strings. And once we get those in, we parse it into A and B, which we add together into the variable C, and then we do a simple output where we convert this into a string and pass it onto console.writeLine, which will output the data. And this way, we have created a simple calculator that will add two numbers for us. The most straightforward, somewhat useful program you could probably create now. Except we can't do the string args in the online editor, so that's a drawback. We can do other inputs though, and we will talk about those next time. Right, and with that, I'm gonna leave you. Have a lovely Sunday, and till next time.